Okay, in this video we will start solving few more problems on MOSFET basics. Okay, okay, this is the exercise problem from Fundamentals of Microelectronics by Razavi, which is one of the textbook for your syllabus. So let us try to find in this figure 6.48 having a specified value of W bell, VDD, RD. Of course, a special case of this is, so there is a channel length modulation, lambda is also given. We are asked to find the value of VB to keep the MOSFET at verge of saturation. So for that, okay, I have written the circuit diagram and a few equations here. So this is the circuit diagram what we are looking at. So we are asked to find VB to keep the MOSFET at verge of saturation, and of course, as we know that we can write this as a KVL expression. So now I can rewrite this expression as VDS is equal to VD minus IDRD. So since VDS should be equal to VDS at, so that's what the condition we are looking for finding the value of VB. I am replacing this VDS by VGS minus VTH, and this will be VDD minus ID into RD. So let me substitute the value of ID as, since we are considering lambda also into picture, which is 0.1 volt inwards. So the expression of ID becomes half Kp W bell VGS minus VTO whole square into 1 plus lambda VDS into RD. So, and then I am rewriting the same thing here. So it is VB minus VTO is equal to VD minus half Kp. This is now VB minus VTO whole square 1 plus lambda. I need to replace VDS. So because we are looking for VDS of VDS at, so can I write this VDS as VB minus VTO, this is my VDS, and multiplied by RD. So now if you can see, this is the unknown parameter, all other parameters are known. But you can also see, so this VB minus VTO is always grouped here, here as well as here. Let me replace this as a variable where A is equal to alpha A is equal to equals 1.8 minus 100 micro, and this is, of course, let me write it using this. This is 20 divided by 0.18, and this is again A square and 1 plus lambda into A into RD is 5 kilo. So now I will look for, okay, this lambda is 0.1 into, so this is 0.1 into A. So if I solve for A, whatever A value I'll get, that will be equal to VB minus VTO. To get the value of VB, so I have to multiply A plus VTO. So let me do that. This is a simplification. Otherwise we can also write it as alpha A minus 0.4 so on. So both are correct. So now what I'll do, I'll look for this. So this is my expression. It is, okay, alpha equals 1.8 minus 100 exponential minus 6 into 20 divided by 0.18 into alpha A square into 1 plus 0.1 into alpha A, close the parenthesis, into 5 exponential 3. We are done. So this is what we have in the equation. So let me start from here. This is what I have. It is alpha A, and then alpha equals 1.8 minus 100 micro into 20 divided by 0.18 multiplied by A square into 1 plus 0.1 alpha A into 5 exponential 3. Shift calculate. So I'll get one of the value of this A, which happens to be VB minus VTO. You can see one of the value is 0.169 volt. This is one value. The other value, what I'll do is I'll just say equals minus 1 equals shift cal. because this is a part of your quadratic equation, I will get two values. Okay, the other value is minus 0.191. So these are the two values which is equal to VB minus VTO. So for this, if I want to get VB, so I have to multiply 0.4 with this, so then this will become 0.569 volt is one value. The other value is, so it is 0.319. Is that correct? No, it's not 0.319. It is 0.4 minus of 0.191, which is equal to 0.209. These are the two possible values. Now since these are the two possible values, this cannot be the answer, so we are supposed to get the value of VB as 0.569. so this way we can able to find the value of VB, which is 0.569. To just verify whether this value is correct or not, so what we'll do is we'll substitute this value of VGS here in this VB and try to find out what is this. So this should be equal to, okay, how much should be this coming out to be? So it is minus 0.4 would be 0.169. I have to get this much answer if I substitute all these values as it is. So now what it is, okay, I'll make it 1.8. that is, let me just substitute in this expression, or you can just take this expression, because we know what is this VB now. For VB minus VT, we already know it as 0.169. So what I'll do is VDD is 1.8 minus 100 exponential minus 6 into 20 divided by 0.18 into 0.169 square multiplied by 1 plus 0.1 into 0.169 close the parenthesis, one more closure into 5 exponential 3. If I solve for this, can you see now you have 0.186. it is 0.186. Okay, what is the answer I have here? It is already a solved problem. Let me find out. Okay, you have this. So this is one of the solved problem. Of course, solved problem means, okay, this I have already shared with you people. So this is how you got the value of VGS as 0.5698. Of course, there is a slight variation in the value that what you will get there. So it is coming out to be 0.186. It's again because of the decimal values that we are considering in finding the value of this entire expression. For when we are verifying, we have to substitute all decimal values, then the value will perfectly tally. Otherwise, the value of VG is equal to 0.569 is a correct answer. So I will show one more video where I'll be demonstrating the simulation part of it. Then you'll certainly appreciate, okay, whatever value that we are finding here will be a proper one. So these are the two possible values, which is 0.569 and 0.208. So that's what we got here also. So these are the two possible values, and we shall move on to next question. Where is this? Okay, it's here. What is this question is all about? So if you see this question number 31, An NMOS device operating with in saturation with lambda equal to 0 must provide a transconductance of 1 over 50 ohm. So now let us try to solve this. So here we have some parameters being given. So transconductance GM needs to be 1 over 50. This is 1 over 50. So we are asked to find what is W by L if ID is 0.5 milliampere. We are asked to find what is W by L if VGS minus VTH is equal to 0.5 volt. We are asked to determine ID if VGS minus VTH is equal to 0.5. So these are the points that have been asked. GM is given as 1 over 50. We are asked to find what is W by L if ID is this much, what is W by L if VGS minus VT is this much, and what is ID. So we have the expression of GM. There are three expressions. One of the expression is 2ID Kp into W by L. The other expression is GM is equal to Kp W by L VGS minus VTO. This is one more expression. The other expression is GM is equal to 2ID by VGS minus VTO. So these are the three expressions of GM. So from which we can comfortably find when the value of ID is given as 0.5, what is W by L. Maybe you can use equation 1 for this. So since VGS minus VTO is given, Kp is known. Of course, Kp you can consider it as 200 microampere per volt square. So this is this much. You can use equation 2 for finding this, and you can use equation 3 for finding ID given this. So now you can straight away solve. So what is this GM? So you can just simply take this first equation, which happens to be GM is equal to under root of 2ID Kp W by L. So I know that this is 1 over 50, so I can substitute as it is. So this is the only unknown. Sorry, W by L is the only unknown. So shall I say it as 50 inverse, which is 1 over 50, alpha equals under root of, open the parenthesis, 2 into ID is 0.5 exponential minus 3 multiplied by Kp is 200 exponential minus 6 into, this is unknown, alpha A, close the parenthesis, one more closure, or only one closure, because I have opened only one parenthesis. Shift cal, it will give me the W by L ratio. So W by L ratio is 2000. Suppose under this condition, if W by L is 2000, you'll get a GM of 1 over 50. So this is your first answer. Second answer is you are asked to find again W by L if VGS minus VTH is this. So now we have GM is equal to Kp W by L VGS minus VTO. So now you have 50 inverse alpha equals, why it is 50 inverse is because it is 1 over 50. 50 inverse alpha equals Kp is 200 exponential minus 6 into, this is alpha A into VGS minus VTH is 0.5. Shift cal. So in this case W by L is 200. So these are not related. So they are simply asking us to find the value of W by L if other parameters are given. Next is you are asked to find ID with a GM of 1 over 50, so on so. So this is the only unknown. I know GM, I know VGS minus VTH. So now GM is equal to 2 into ID by VGS minus VTO. Is it not again 50 inverse alpha equals 2, okay, let me open the parenthesis, let me open the parenthesis, 2 into alpha a divided by, open the parenthesis, of course divide by 0.5 close, shift cal. So now what is ID? ID is equal to 5 milliampere. ID is 5 milliampere. So this way we can comfortably find the values. Okay, in order to do this problem I have to know these equations of GM, and if you know the GM equation then it is very easy. So again we need to put the unknown on the left hand side and all known thing on the right hand side. That stuff, okay, it need not be written, so you can directly write the answer by doing it on the calc. So this is what is 6 point, what is that number, I don't know. Okay, let me see what's the number. It is 6.31. So this is chapter number 6. Let us move on. Okay, there is another problem, 6.32. Determine how the transconductance of a MOSFET operating in saturation changes if. Oh, we are asked to find how does GM changes under following conditions. Let us try to understand the three conditions, ABCD conditions that have been given. So what is GM? In first case, W by L is doubled, it is 2x, but ID is remaining constant. Now B, VGS minus VTH is doubled 2x, but ID remains constant. C is ID is 2x, but W by L remains constant. D is ID is doubled, but VGS minus VTH is remaining constant. So this is constant. Okay, let us see what happens to this. How do we solve this? So we have three equations of GM, that is, what is that I have written here. And now if you can carefully see these three equations, okay, let me just show you this. Okay, we have, okay, let me just put this here like this. Okay, these are which I already written. Let me not rewrite that again and again. Okay, fine. These are the equations I have. So GM is one equation where you have, so the W by L is increasing 2 times, but ID is remaining constant. So if you want to use this relation, I may have to use the equation number 2, because here ID is not there. So let me use equation number 2. If you can see here, if W by L increases and ID remains constant, then GM will increase by 2 times. Because if this increases, Kp is there, VGS minus VT is there, so your GM will also increase by 2 times. It will become 2x. That's what is the first A is. In the B, VGS minus VTH is doubled, ID remains constant. So for which I should not have VGS and ID together, it's again the equation number 2. So I have the equation number 2 where VGS minus VTH is increased 2 times, but ID is remaining constant. So can you see this GM will also increase by 2x. This will also increase by 2x. Next you come to this. You are increasing ID by 2 times, but W by L is remaining constant. So where you are increasing ID and W by L, so where you have ID expression, where you have ID term but there is no W by L. So can you see this here? So if you can see this, if you increase ID by 2 times, GM will also increase by 2x. Next is, if ID is increased by 2 times, keeping VGS minus VTH constant. So this is your increasing ID by 2 times, but VGS minus VTH constant. So in this entire expression, so okay, here I wrote equation number 3. Why it is equation number 3 is ID is there, but there is no W bell. So because W bell is constant here. So now over here you are increasing the value of ID by 2 times. VGS minus VTH is constant. Among this equation which has ID but there is no VGS minus VTH, maybe this equation. Of course it is this equation, equation number 1. Suppose if you are increasing ID by 2 times without increasing VGS minus VTH, so then what is the increment of GM? This increased by 2 times, then GM increased by root 2 times. This is increasing by root 2 times. It's not by root 2 times, so this is by root 2 times. So this is how we have to solve this problem. This is how we have to solve this problem. Again, to write this equation, to solve this problem, we have to know these 3 equations. So you look for out of these 3 equations where W bell and ID both are not there. So it is this. This is the only equation where you have W bell but there is no ID. In this equation, or you find the equation where you have VGS minus VTH but there is no ID. It's again equation number 2. Over here you should have ID but there should not be W bell. So it is now this equation. That is equation number 3. Next you should have ID but there is no VGS minus VTH. It is this equation, equation number 1. So this is how the GM changes as one of the parameter keeping other parameters keep on changing. Hope it is interesting. So you may be wondering, okay, how can I increase W bell without increasing ID? Okay, these are the possible things that happens in MOSFETs. So we will just try to do all these things when we actually do some simulation. So this is really interesting. Okay, next is 33, problem number 33. Okay, let me just go back here. So let us solve this 33. So if lambda is 0.1 volt inverse and W bell is given, construct the small signal model of each of the following circuit. So we are asked to find the small signal model. We are asked to write the small signal model. So we know that okay, let me write what is given there. So we have been given lambda as 0.1 volt inverse. W by L is given as 20 divided by 0.18, and that's it. we are asked to find okay, so many things. Okay, small signal model. The first circuit is this. So I have this as 1 volt. This is M1. This is 100 ohm. This is VDD. Okay, let me try to write this. Okay, we are asked to find the small signal model of this circuit under these conditions. So we know that of course lambda is non-zero. So I can replace this entire circuit by its AC equivalent in the first stage. I replace the DC voltage by the AC ground. You can see now this is AC grounded, and I have this as 100 ohm. This is again actual ground, and this is also AC grounded. This is also AC grounded. See here. So this is first stage. This is RD. This is RD. This has become 0. So next is I have to write the equivalent small signal AC equivalent of this MOSFET. So now the gate is grounded. This is source, and I have this as gate here. This is drain, which is having GM into VGS is my current source, and this is R0. This is R0. So this is the small signal model. If you can make out, of course I have a RD which is connected from drain to ground. So this is RD. This is RD. So now I know the value of RD as 100 ohm. I have to find what is R0 and GM. What is this R0 and GM? I have to find. So what is R0 is equal to? R0 is actually 1 over ID into lambda. What is GM is equal to? GM is equal to under root of 2 ID Kp into WL. So this is what is GM is. Can we find the value of ID? Yes, we can find the value of ID here. So what is ID expression? ID is given by half Kp W by L VGS minus VTO whole square into 1 plus lambda VDS into 1 plus. Why this is 1 plus lambda VDS? Because the lambda is not a zero quantity. So this is a channel length modulation parameter. So let me write this equation again here and find the value of ID and then find the R0 and GM simultaneously. So now this is ID is equal to half Kp W by L VGS minus VTO whole square into 1 plus lambda. VDS is actually VDD. This is VDD minus ID into RD. ID into RD is 100 ohm. Okay, let us substitute all these things. So it is now alpha A. That's what is this. Let me put this here. This is alpha A. Alpha equals 100 exponential minus 6 into WL is 20 divided by 0.18, that's given, into this is actually 1 volt. 1 minus 0.4 is 0.6 square multiplied by 1 plus 0.1 0.1 plus 0.1 into VGD is 1.8 minus alpha A into 100. That's what is RD. Close the parenthesis, shift cal. So this has given the value of ID as one of the value of ID is equal to it's not one of the value, it's the only value. 4.53 milliamperes. So 4.13 milliamperes is your ID value. So 4.13 flows in this MOSFET into 100 would be very less voltage. So it's actually 0.453 volts. Okay, it is in saturation. So this is the value of ID. So if this is the value of ID, then what is R0 is equal to? So ID is found. I can find what is R0 is. What is R0? It is 1 over ID into lambda. So it is 0.1 into 4.53 exponential minus 3 whole inverse. So it is now, I can just do this, it is 2.2 kilo ohm. It is 2.2 kilo ohm. So what we did is ID into lambda 1 over. So ID is 4.53 exponential minus 3 into 0.1 equals, and then whole inverse of this, which is pressing engineering, you will get as 2.207 milliamperes. So that's what is R0. How about GM? GM is under root of, open the parenthesis, 2 into 4.53 exponential minus 3 into 200 exponential minus 6 into W value is 20 divided by 0.18. 2 parentheses or only 1 parenthesis, it is 2. This is one and that is another. I'll get the value of GM. So now GM is, you can press engineering, you get it as 14.18 millisiemens. This is 14.18 millisiemens. So this way, this what is the value of GM, this is the value of R0, this is the small signal model. So we have constructed the small signal model whose this is actually VGS, small VGS, and we have a current voltage dependent current source with a value of GM into VGS. The GM is 14.18, R0 is 2.2k, RD is 100 ohm. So this way we can able to construct the small signal model of this given MOSFET circuit. So let us find the other problem. Okay, shall we? Okay, we will do it for now. This is almost half an hour. Okay, let me stop it here now. So let us do the other problems in the next video.